Here's a problem that you might run into. Say that you've been given a nested dictionary, that is, dictionary inside of dictionary. In this example, say that we've given a dictionary indicating keys of integers that show the page number, and the value is a dictionary that contains all the attributes of that page. The attributes dictionary has all the different items like header, body, and footer, as well as their values. In this example, I said H1, B1, F1. Say that we're given the task of writing a function that's going to return an output of lists that flatten by the page numbers. So if we were to take page 1, we're going to flatten it into a list that has all of the values inside of the dictionary. So H1, B1, F1, and same thing goes for the 2. Page number 2 has all of its items flattened out, H2, B2, T1, F1. So how would you go about writing this function? Well, you would first input the dictionary. You would also want to return the output. That might be it. We could go with the naive approach and create a nested for loop to accomplish this goal. So let's see what we would have to do. So for, let's call it page key and page dictionary in one.items. We first want to create an empty list. We'll call that item for each one of the pages. Initialize an empty list. What would we do first? First, we'd add the page key. That's easy enough. We would simply append page key. Great. Now what? Well, now we're going to have to do the nested for. And we want to add all of the values inside of the dictionary. So we know that this is going to be the page dictionary. All we would do is say for, I guess we can call it value in page dictionary dot values. To the item, we would append each and every one of these values. Once we're finished with that for loop, we know that we're finished. We're done with the page. So we can add that to, let's say, an output list, and we'll add it to the output list once that loop is finished. Item. I'll have to make it a copy because of the call by reference. Once we've gone through the entire dictionary, we're going to return our final output. That would be it. Let's give this a shot. There we go. 1, H1, B1, F1, 2, H2, B2, T1, F1. Easy enough. But say I'm going to throw a curveball. Say that inside of these dictionaries of all the page attributes, we can have another nested dictionary. So perhaps we can say that there'll be a table inside of a table, or we want to show all of the rows inside of this table. And instead of having just a single value there, we're going to add another dictionary value. So all this R1, say the value is 100. Say row 2 has a value of 200. Not only that, we let's just assume that we don't even know if there could be another table inside this. We can have, in fact, another table inside of the table. For row 3, we can call that, I mean, we could call that row 3, I suppose. But we'll have even more rows. So we can say RR, RR1, value of 1,000. Now, we want to write a function that's actually going to flatten this out completely. So instead of T1, H2, F2, T1, we want to return all the rows values, 100, 200, and if there's a table inside of the table, we want to return that value. We want to completely flatten out this dictionary, nested dictionary. Okay. So that obviously complicates our function a bit. What are some things that we know? Well, we do know that the first layer is always going to have a key value of the page integer. That's one thing we could do. We can know for sure. What we don't know is the dictionary inside here. We have no idea how many for loops that we need. If that's the case, we're either going to have to do some sort of depth first or some sort of recursion to make sure that we pull in all of the values. You can immediately think that we can check if the value is an instance of a dictionary, we would know to recursively call the function again. In order to make sure that we're going to separate this out into separate lists inside of a list, we'll probably have to have two functions. We'll have to have a helper function, one that's going to iterate through the entire dictionary, and one that's going to flatten out completely what's inside of that dictionary. So let's first write a function that's going to help us out and flatten out the dictionary completely. Now we can't use that because we can't use that on the example itself, because if we did, it would flatten this out completely. It would disregard separation between the page integers. So keeping that in mind, let's make our helper. Pass in a dictionary, pass in the item that we're building, and perhaps we can also pass through our final output. It's going to be this or this. Okay. So again, we're going to iterate through not the page key, but we'll just call it key value in two items. And what's the first thing we want to check? Well, we have to check, is the value a dictionary? Because if it is, we want to recursively call the function again so that we could go through our logic another time. So if this instance, I believe is the term, the value is a dictionary, okay? We know that it's a dictionary. We're going to call this helper function again. This time, we're going to input value as well as the item we're building and our final output. What if it's not, though? What if it's not a dictionary? Well, and all we would do is append value onto the list. So you can imagine that if we were inside here, this isn't a dictionary, so we add that. This isn't a dictionary, so we add that. This is, so we have to recursively call and move into this dictionary to go through the for loop. We'll check here. This isn't a dictionary, so we'll add that. This isn't a dictionary, so we'll add that. This is a dictionary, so we'll recursively call again, and so on and so forth. Now, once we've gone through this entire nested dictionary, we need to figure out how we're going to add that on. But before we get there, let's see what we have to output. Well, after we've gone through this entire loop, I suppose we can just output what we've entered. And the reason I'm doing this is because say that I was going to initialize the output like this. Well, every time we call it, it's going to get rid of it. So in order to avoid that, thinking about it through more, I think we might be able to simply return the item. That's going to build and build all the way to the very end. So we might not even need this. Okay. Well, let's give this a go and see if this actually works. We can just pass in through empty item. And this should return a completely flattened out list of all of the values. Let's see. Find it first. Ooh. It is not defined. Oh, of course. Sometimes to lose track. Okay, so let's see what happened here. We added H1, B1, F1, yes. H2, B2. Oh, did I not define this yet? Okay, let's try that one time. All right, that actually worked out better than I'm used to. So it did flatten out everything, and you can see we didn't add. The only difference here is that we flattened out all the values, and we didn't separate it by the page number key. Okay, that's gonna come in handy when we go through logic out here. Okay, so again, this remains the same. We can say we know that it's going to be a page key and page dictionary in the first layer. We will first create an empty item, and we'll append the page key. Great. Now what? We know that the page is going to be a dictionary on the first layer. So call our helper, pass in through page dictionary, as well as the item. It's going to be empty. It's going to append all the values that we need. And would this work? Well, Get a copy of the item. So I'm not entirely sure if this will work. Let's give it a shot. Out. We're just going to enter the dictionary. And it looks like it did it. We got our first list. 1, H1B1, F1. 2, H2B2. 2 rows first, and then the row inside of the table inside the table. We could do some variations here where we can add the name of the attribute, indicate where it separates out. All we would do to do that is probably add the key in front of the item before we call in the recursive helper. Something like append key. It call the table. Yeah, so obviously I didn't think this through too far, but it did do what we're trying to accomplish. There might be slight variations depending on the format and structure of the nested dictionary. But there could come in times where we would need an output like this for inserting it into a table or creating a flat file, various reasons. So I think that concludes flattening out a dictionary. Hopefully this gave you an idea of my approach. There are many different ways to go about this. So give it a shot. Thank you.